last couple of labs, which actually are technically our first two labs, right? Um, Ideally, whenever we're doing our labs, okay, we're gonna have a different intro, lab or die, okay, for those actual labs. Now, they were short, they were quick, okay, and they gave you the basics, okay. However, in the background, like with the VTP, okay, all right, I wasn't expecting VTP to do what it did originally when those VLANs propagated. So, as far as the lab was concerned, okay, I left it that way. Okay, it was the easiest way to do so, just to show you how easy it is to get your VLANs wiped out and replaced, okay, with another VLAN database. So, what you're supposed to take from that is, okay, making an extra step of recognizing VTP can damage your network, okay, can bring it to a streaking halt, okay, where no data goes anywhere, all right, across your entire switch domain, and understanding how VTP functions, okay. But one of those Easter eggs, okay, if you want to call it that, is the search online what I did, which was what? Requirements. Okay? That in itself, the word Cisco, the technology, and requirements is something you, okay, now have the power in your pocket. Okay? Now, when I say power, I mean, an added tool to your troubleshooting and for your configurations. Okay, because requirements, Cisco is going to list what is necessary. Okay, and this in itself, in order for that technology to work, by the way. Okay, because some things are platform specific. Okay, some is iOS specific. Some is version specific, meaning that they have to be the same version. Okay, so on and so on. Now, with that being said, okay, all right, do not take the first two labs as a sense of normacy or the norm. Okay, because as we get into other technologies, that labbing is going to be a lot longer. Okay, yeah, I'm not gonna say that 3 times. So, our next topic. Whoo, spanning tree. Okay. Remember those ports being amber every time we plugged them in? Okay. And we had to wait for them to turn green. Now that, my friend, is spanning tree in the background doing its job. Okay. Now, what is spanning tree? Okay. I'm gonna. I don't like the analogy, but hey, it works. Okay. The concept of this is, here is switch one. Okay, right here. Okay. This is switch one. This is switch two. Switch one sends out a broadcast message. It goes over to switch two. Well, what happens to a broadcast message that comes into a switch port? It gets flooded out of all ports except the one it came in on. Okay, so this is port one, this is port two. Okay, switch two gets a broadcast on port one. Port one is going to send it out port two. Switch one is going to get it on port one. Now, wait a minute. Isn't that inefficient? I'm the one, switch one, who sent out the broadcast message. Why would I want to get that message back? Okay? But I am getting it back. And what am I going to do with that broadcast message? Remember, every switch just does its job. It's going to send out a report except the one that comes on, except the one that comes in on, and now it's going to go back out switch one, hitting switch two, coming back around and around and around and around. Okay? Now, if that broadcast message is sent out and those switches happen to respond to those broadcast messages, okay, and it keeps going around and around and around, aren't I going to keep responding and responding and responding and responding, okay? And now I got responses and requests floating around, looping around. Anytime that I have more than one cable or a loop in my network, okay, meaning that I can have 4 switches and every one of them are connected in a circle, that is a loop, okay? All right, so let us, I don't have Visio up. I gotta get that fixed. Come on. I'll be glad when I get a drawing pad. Okay, where are you? Where are you? Where are you? I found you. Okay, so now. Come on. Come on. I hate when I can't get that damn square back. Okay? Now, here's our network topology. Alright? What is a topology? Just how things are connected. Alright? Now, anytime you're dealing with me, this is going to be switch 1, switch 2, switch 3, switch 4. Okay? Alright? No need to write them out. Okay? Especially for this example. My connection is great. Okay? However, we in our networking field, something that you are going to start learning is redundancy. Okay? If this link here fails, okay, I lose access to what? Switch 4. If this one fails, I lose access. Switch 1 and 3 loses access to 2 and 4. So I want redundancy. So we're going to actually have another line here. Okay? Now this is nice because, come on, if this link does fail, okay, and goes down or gets cut or removed or whatever, I still have access to all my switches. Okay? However, in this state, I have a physical loop. Okay? Now, in the background, what spanning tree does is when you first plug a port into, or a device into the port, it does not forward traffic. It stops and waits. Okay? Alright? This is spanning tree doing its job. In the background, it is looking for loops. Now, I'm going to see if I can actually search for this. You never know what it will come up with. Okay. Alright. Here we go. Oh my god. Okay. See, you never know what Visio will come up with. Alright, now, ideally, the concept is where we have a loop, okay, when spanning tree detects a loop, it's going to determine on every switch which ports are allowing traffic to come in and go out, okay? And somewhere in this topology, I am going to drop a tree on that particular port, all right? In this case, I am dropping a tree on switch 4. I couldn't even remember my own numbers. I'm dropping on switch 4 on switch 4 side. That means that, where are my lines? Where's my arrows? Did I do that wrong? Yes, I did. Boom. Arrow. There we go. Okay, so now this is, come on, go back to my pointer. I'm allowing traffic. I hate when I do that. Go back. It's control, not shift. Okay? I'm allowing traffic. I'm allowing traffic. I'm allowing traffic. Okay, so now there's no point of pointing the arrows in the other way as well. But of course, this is allowing traffic going here. This is allowing traffic going here. The only way I'm killing the loop, which is exactly what I'm doing, I'm killing it because here, okay, is going to be, which I do not have an X, so I am going to make one. Boom. Okay, horrible X. Let's kind of fix that. Okay, all right. So there is my X, and I am going to group it and change the line color to there. Actually, here we go. None of these are turning looking red to me. Really. Okay? I am going to X out and close this port from being allowing traffic to come in or forward. Okay? Killing the loop. Okay? Don't ask me why they use trees as dropping a tree on the line. I don't know. Okay? But it's still comes up with a cool name called spanning tree. Now, okay, that tree that we're going to get rid of, okay, is now killing any loops in your network. Now, think about this, okay? Now, okay, if that link is there, my topology from a virtual concept is going to look like this. Because that link is no longer there because it's not allowing traffic on one side of the link. Okay? Now I have a loop-free topology. Beautiful. Okay? And now that loop-free topology, I don't have to worry about broadcast storms in that sense, blah, 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 blah. Now, with a misconfiguration or poor design, okay? Now, poor doesn't mean negative. It just means you forgot something or you just designed it wrong. Okay, all right. Now, from this concept, the right and wrong concept is you wanted a loop-free topology, but you designed it where loops were allowed. Okay, all right. You had a misconfiguration somewhere which allowed the loops. Okay, all right. So from that concept, you failed to do what you were trying to do, and from your perspective, it's a wrong configuration, right, or wrong design. Now, imagine, okay? Imagine this happening, all right, with many switches. And you know what? I got the perfect program to show you. Let's hope I can download it. Okay, am I downloading this from Cisco? No, it says Netcat. So I don't think I have a password for that. I guess I cannot get that. Is this a free download or what? That looks like a packet tracer course. Okay, now this is completely spontaneous, by the way. Okay, this was not my plan, so just bear with me. We do on the fly training here, guys. All right. What I like to call it is a freestyle teaching method. We go with the flow. La 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 la. God, I haven't used packet tracer in decades. I mean, I can't really say decades because I started my network training in 2009. Okay, so I used packet tracer in my CCNA days to get me familiar with how things changed on a hop by hop basis as far as the headers were concerned. Because the switches I had were not adequate for my studies, and it helped me till it didn't, and then I went to real switches, and then I never touched packet tracer again, except for what we're doing today, and that is to explain span and drain. Okay, let's go ahead and launch it. Okay, I don't know. Okay. Close. Failed to log in. It's shutting down. Okay, that was interesting. Um, Maybe this time I'll read what it says. See, this is another thing. I didn't have to go through all this crap before. Cisco Packet Tracer sign in with one of the using Network Academy. Okay. I'm already getting annoyed. Okay, so that goes back to here. If I have to log in with forget it. All right, it shouldn't be that difficult. And you know what? Let's go and see if I have a older version. No, I don't. Yep, there we go. There it goes. This is why you should always have backups and redundancy of your backups. You'll never lose data. And this data is from God knows how long ago. That says 2014, but our original version, you know what? That is not accurate at all. There we go. Okay. That looks familiar. Da, 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 da. Okay, now. Come on now. Okay. Notice they are red. All right. Well, let's turn it on. Wait a minute. Hold on. We are already on. All right. Let's bring this over here. No shut. Oh, you know why? Crossover cable, guys. Crossover cable. There we go. Okay, so now look, they're amber. Okay? This is spanning tree doing his job. Okay? Making his calculations in the background, making sure there's no loops, and eventually it'll go to green. Okay? Okay, so now they're green, just like on the real switch. Okay? So let's go back over here. Boom. Boom. Crossover cable. Alright, let's wait until they turn to green. Now, every switch port does this on a Cisco switch, unless you turn spanning tree off. Okay, which eventually you'll learn how to do that. Now, okay, so now we're all green. But what happens if we have this connection here, which will cause a loop? Let's see what spanning tree does. Okay, notice it makes this amber. Okay. All right, right off the bat, it blocks this port. Let's see what it does with these two ports in this link. Okay, so before these ports even went green, Spanning Tree had already made a decision to place a tree on this link here. Okay, making the topology loop free because data cannot go from switch 2 to switch 0. Okay, this is what spanning tree does. Okay, now we don't want to wait for such a long time for ports to be enabled because what will happen is our DHCP requests that go out will not come back in a timely fashion. So we need to turn that off. Okay? All right? And that command is called port fast, but we'll learn about that later. All right? So imagine now. Let's go ahead and get rid of this link. Okay? And let us add another switch here. And let's do this. All right, give me 1 second. Okay, so now let's go to our okay. Now we have our redundancy in. Okay. Now, let's hang on. So I'm going to go over to Visio now. Okay, now, and I'm going to show you here on Visio what the physical, not the physical, the logical loop-free topology Spanish has created, okay, by removing the blocked links. That is how your traffic is moving now because of Spanish. Now I could actually make this topology function as every hop from one switch to the other is a maximum of 1 hop, okay? If I know how to manipulate Spanish, okay? All right, and make my links the way I want them to be. Okay, but right now, as you can see, 1, 2, 3, 4. Okay, that's 3 hops away. Okay, all right, at the max hops as this spanning tree on Packet Tracer has set up and made it a loop-free topology. Okay, now ideally, the cool thing about this is if one of these links die, okay, which let's go back over here. This link dies. Okay? We're going to kill that. And kill this. Okay? And now, we'll give it a little bit. Make sure it's calculated. Alright, which I believe it is already calculated. Okay, once that link dies, spanning tree in the background is going to recalculate. So now let's take a look at our loop-free topology. Kind of same, right? Okay, so now let's go back. Okay. And let us kill one of the links that are live, like this one. Okay? And we'll give it a minute. See if any of those ambers turn into greens. Which I don't think it is. Alright, so let's go ahead and delete. Okay, now you see our new topology. Okay, after one of our links failed, this is our new link topology. Okay, that 3 hops away is now gone. Alright, spanning tree does this automatically in the background. However, your understanding of the spanning tree as we go through this, you're going to be able to make sure that your topology is the way you want it to be. Okay, so at this point, I want my devices, okay, to all connect to 1 hop away. So what I'm going to do is I am going to restructure by adding a switch in the middle here. Okay. Okay. Now, let's make our redundancy. Okay, now, 1, 2, 3. All right. Let's get rid of all these. Okay, so now, the way we have this set up now, okay, let us take a look at our topology, okay, based on what spanning tree came out with. Okay, what is going on here? Did you... Okay, that needs to go bye-bye. I don't know how that happened. Okay, so now this one is gone. This one's gone. This one's gone. This one's gone. Okay, so in order for this switch here to get to this one, or this one, 1, 2, 3, okay, if the traffic is going this way, okay, to the middle switch, 1, 2. All right, so let us go back. And now let's log into this switch. Okay, we're still going through our phases. Okay. Now notice we're still waiting for one link to finish. Okay, so what I've done is now I've made it so my spanning tree, okay, that the middle switch, all its ports are forwarding. So now let's take a look at our spanning tree loop-free topology. Why are you doing this? That's one. Okay, so now this one goes bye-bye. This one. This one. This one. And this one. Aha! Now that, my friend, is a nice look in loop-free topology that I want to see, that I got to control by my managing this switch in my method. Okay? Much better. Okay? Maximum hops is 2 hops away instead of 2, 3, or 4. Okay? Alright? Now, that means all the traffic going from the top layer to the bottom layer has to transit a middle switch. Meaning that you might want to have that switch kind of a better throughput than the other ones, because it's going to be handling a lot of transit traffic. Alright? But nonetheless, spanning tree at its finest. Okay? And all I did was make a simple change. But you saw how long it took these block ports in the middle switch to move to forwarding. Okay? Alright? And this is the concept of having a loop-free topology. Putting in loops for redundancy to have a loop-free topology in the background, so if one of those links fail, spanning tree can recalculate and unblock one of those ports to keep that path to that switch going and valid, and still keeping it loop-free topology. Okay? Alright? And that is where we end. Okay? This will be our next video, and I will see you guys on the next one.